17CV055 Manish. I'm taking them out.
Sir, it's up,
So
sir.
no, I don't see your profile picture.
I'll leave and join another time, sir.
Okay, you can leave now. And also 17CV060. You can leave 17CV060. So Puneet and Ravi Kiran, I cannot say anything.
I think from next class onwards, even I will try to put my ID.
Okay. 18CV 100. 18CV 100. I don't see your picture in your, that is ID card in your profile, and also Prajwal CV072. So you can join later. As of now, you can leave. Okay, Prajwal 072. Okay. So coming back to this, bolted connections. Yeah, this module has two parts. One is bolted connections and the other is welded connections. So in case of RCC, as I explained in the classroom, I think I took 4 classes for B section, but for the rest of the sections, I don't know about that. So when I explained in the classroom, when in case of RCC, we don't worry about the connections. We only design structural elements like RCC elements, beams, slabs, columns, footings, etc., and individually, and we are going to put them together to make a structure. Okay, thus then we are going to put first reinforcement, and we are going to bend the reinforcement as per the requirement. So cut it, bend it, whatever way we need to do, we are going to do it. Then put concrete. Okay, and once the concrete is set, cure it, and take the scaffolding or supports out after certain days, 21 or 28 days. Then the structure is going to act monolithically as a single unit. But when it comes to a steel design or steel structure, so here the structural elements consist of beams, columns, okay, footings, that is column bases. And here we don't design any slabs. Okay, keep in mind, we don't design any slabs. So when we design structural elements like beams, columns, and also we extend columns or beams beyond the length of that particular member available in the market, so we need to connect them. So connection is very important. Okay, here. So when you design a connection, so you should, design it little bit extra, that is, you need to give a little bit extra importance for connection rather than an individual member, because any individual member, any failure is going to be gradual, because the steel material is ductile. It is going to give enough warning before it fails. But when it comes to the failure of the connection, it does not give any warning, thus the failure is sudden. So you will have to be careful when you are designing connection, and also the IS code adequately covers it. Okay. So coming to this, mainly we have 3 types of connections: rigid connections, flexible connections, and semi-rigid connections. I'm going to glance through it, so you don't have to worry about this part. Just for your sake, I'm showing this. So if I had taken the class, I would not have shown this, and I would not have covered this part, because it is not required, because it is there in my notes already. Even though it is not very important for the examination, I go and glance through it very quickly. Okay, so these are all rigid connections. If you look here, this is a column. When you look from the top, you are going to see the I section, and this is a bracket connection, and this is a rigid connection, because even the moment is developed at this. So this is a bolted section. So bolt is represented by plus sign or a circle. Okay. So if you look here in the second figure, so again, it is a bracket connection, and you see these lines, small lines at 45-degree angles. So those are the symbols to show the welded connection. Okay. Then here is beam to column connection. This is the column. Vertical member is the column. Horizontal member is the beam, and they are connected through welds. You can connect through bolts or welds. In this case, weld is shown. So here column to column connection. So any I section has certain limitations as far as its length is concerned. So when we are extending that length of the member beyond the limiting length of the member available in the market, so what we need to do is we need to connect the lower part of the I section and the upper part of the I section through the connections. Those connections are called splicing. Okay, this is called column splicing, and we are going to put plates on both faces, and we are going to connect them using bolts or welds. Here, this is beam to beam connection. This is the beam ending at this point, and we need to extend this beam. So we need to extend this beam by providing the same section, okay, and connecting those two sections using bottom and top splicings. These are beam splicings. Okay, this is also a splicing, and these are connected using bolts. If you look at this plus sign, and also if you look at these vertical lines, these are all bolts. Okay, so this is flexible connection. In this connection, so the joints will not take any moment. Okay, they only transfer the reactions. But in case of rigid connections, they are going to transfer both reactions, that is load, as well as the moment. So these are the examples of flexible connections. So then comes semi-rigid connection. Again, semi-rigid connection is going to be like this only. Okay, so how to make it semi-rigid? To what degree, to what extent? We can make it or 50% semi-rigid or 75%, 25%. So that depends on the requirement. So because it is beyond your syllabus, you don't have to worry about all these things. Okay. So these are the questions. Briefly explain different types of bolts. So this is in 2017 examination carrying 4 marks. So mention the bolt terminology with a neat sketch. These are all the questions. So before going, so first we need to worry about the bolt. Okay. So that is the component when you are designing a bolted connection. That is a very important component through which we are connecting the bolts. Okay. See, this is the way a typical bolt looks. Okay. And from this is the head part, and this is the length of the bolt. This is the length of the bolt. So the length of the bolt has two parts. One is the shank part, okay, and the other is the threaded part. Okay, and D is the diameter. And all other dimensions of the bolt and the nut are fixed based on this diameter of the shank. That is called the nominal diameter. Okay, and if you look here, so this is the bolt head, and how much is the diameter of the bolt head? 1.65 times D, where D is the diameter of the shank. Okay, similarly, when it comes to the height of the bolt head, it is 0.65 times D. Okay, so when you come to the nut, so it is 0.8 D, and again the diameter is 1.65 D. So you see some numbers within the brackets, that is 1.9 D, 0.65 D, D, 1.9 D, etc. That is within the brackets. See, whenever I say 1.65 D or 0.65 D, if you look down below those two bolts, you see nut and bolt within brackets, high strength nut and bolt. Okay, so whatever bracket value is given is applicable for high strength nut and bolt. Okay, so that means if you take high strength bolt and nut, so the diameter of the head is equal to 1.9 D, whatever is there in the bracket. Okay, so that is the way it is. Next, coming to the details of a joint, if you look here, see, these are two plates which we are connecting. Okay, so this plate is coming over the other plate, this plate. This is called a lag joint because one plate is coming over the other. So what is the width of this? This is the thickness of the plate. This is the thickness of the plate. And the width of the plate is perpendicular to the paper. Okay. So when we are connecting these two plates, we are going to drill a hole of certain diameter and we are going to put the bolt. Before putting the bolt, we are going to put insulating gasket here and here. And also we are going to put steel washers as you look. Then put the bolt. Then put the nut from the bottom and tighten it. Okay. So again, this is the way a typical connection is made when we are designing a bolted connection. So we are not going to take into account the insulating washer and also the steel washer. So this is done only during assembly. When it comes to the design, we are not going to deal with the steel washer part and also insulating washer part. Okay. So this is a typical butt connection of two plates, and I'm going to deal with this later in detail because I have a better figure than this one. Coming to types of bolts. So we have different types of bolts. So we mainly deal with 4 types. One is black bolts. Another name for black bolt is unfinished bolts, grade C bolts, and also it is ordinary bolt. Okay. So that is represented by grade 4.6. So I'm going to talk about what is grade 4.6 later by taking some examples on that. Okay. And the other is turned bolts, rib bolts, and also high strength friction grip bolts, that is HSFG bolts. Okay. These are the main 4 types of bolts. So when it comes to the design, so we only concentrate on A, that is bolt type A and bolt type D. So bolt type A is used, okay, in case of bearing type connections. You will know what is bearing type connection. And friction type connection design, we are going to make use of high strength friction grip bolts. Okay. So these are the explanations for each of those bolts. So which I am going to skip. You can do it, you can study on your own. Okay. So here, when it comes to a high strength friction grip bolt, see, we are going to transfer the load through friction. See, here we have 2 plates and each plate is subjected to a force of F. And we are trying to connect those 2 plates by bringing those 2 plates face to face. So what is the width of the plate? It has certain width perpendicular to the paper. Okay. So when we need to connect and we need to transfer the load through friction, we are going to make use of high strength friction grip bolt. So for that, what we do is first we are going to bring these 2 plates face to face. Okay. Then we are going to put 2 cover plates, then drill holes, 1 on each side. Okay. So once that is done, then we are going to put the nuts and we are going to tighten the nuts. Okay. So when you tighten the nuts, there is going to be deformation in these bolts. Okay. So as a result, the bolts are subjected to tension. In turn, those bolts are going to apply compression on these 2 plates. Okay. So when you apply some force, there is going to be friction developed between the steel cover plates and the main plates surfaces here, and here. And this friction is going to be made use of to carry the external force F or to withstand the external force F. Okay, this is what friction type connection is. So we are not transferring the load through any bearing, and the function of the bolt is to apply compression on these plates, not to transfer load, but to develop friction between the steel cover plates and the 2 main plates. Okay. As I said, I have shown only 2 bolts, but it is not necessary. See, 2 bolts means 1 bolt on this side and 1 bolt on the other plate. So it is not necessary that we have to provide, or we can provide only 1 bolt. No. So depending on the design requirements, so we may need 2 bolts, 3 bolts, 4 bolts, or 10 bolts, 20 bolts. Okay, if that is the case, we are going to provide bolts in different lines, and when you look from the top, you will see the number of bolts in a line. Okay, so here what we have shown is only 1 bolt on each side. Okay, next, coming to advantages and disadvantages of bolted connections. What are the advantages and what are the disadvantages? You can simply read those things. Okay, and I don't need to explain this. And here, these are the questions, and these questions appeared in different years of the examination, carrying different marks. Next, advantages and disadvantages of black bolts. Black bolts are ordinary bolts, okay, or grade C bolts. It is one and the same. So what are the advantages and what are the disadvantages? Similarly, advantages and disadvantages of HSFG bolts, that is high strength friction grip bolts. So these are the advantages and these are the, and we have several disadvantages as well. Okay. So when it comes to installation methods, so it is not there in your syllabus. I'm going to skip this part. Okay. So when you get the notes, I'm going to mark X on this. So you don't have to study for the examination. Okay. Next, we'll deal with types of bolted joints. So questions keep appearing in the examination on this. So if you look here, so we have 2 plates. Okay, this is an isometric view I have shown. So when you look from the top, this is what you are going to see. So when you take a cross section, look from the side, this is what you are going to see. So that is section. Okay, so this is a lap joint. Lap joint means one plate is coming over the other. And how many bolts we have provided? We have provided 4 bolts in a line. So this is a single bolted lap joint. Why we say single bolted? Because there is only one line of bolt. That line we are going to measure perpendicular to the direction of the applied force. This is the direction, and we are applying the force P. Okay, and this is the line which is perpendicular to the application of the force. That is, if you look here, plan, P is this and this is the line. So along this line there is only, bolts are located along only one line. That's why we are going to call that as single bolted lap joint. Okay, so similarly when you look here, again depend. So this design requires 8 bolts. Okay, we have to accommodate those 8 bolts within the width of the plates. So of course we cannot provide 8 bolts along the same line, because we have to maintain certain minimum distance between bolts, between 2 successive bolts, and also we have to maintain certain edge and end distances. So I'm going to tell you what edge distance is and what end distance is. So to provide 8 bolts, what I have done is I have provided 4 bolts on this side and 4 bolts on this side. That means I provided bolts along 2 lines. This is one line and this is the other line. So it is double bolted lap joint. Double means we have provided bolts in 2 lines. Again, I repeat, and that line is going to be perpendicular to the direction in which we are applying the load P. Okay. Similarly, if you look here, so we have 2 plates. So 2 plates coming face to face. So this is not a lap joint. So lap joint, 2 plates, 1 plate coming over the other. In case of this one, here in the figure, 2 plates are coming face to face. This is called a butt joint. That means one plate is butting against the other. So it is a butt joint. So when we are connecting, we are going to provide plates on one side or on both sides. So in this case, the isometric view, what you see is this. Okay, in the plan, this is the way we are going to see. So this is the line at which these 2 plates are mating. Okay, that is coming together. Okay, and we are going to provide only 1 plate, and we are providing bolts on only one line. So again, it is not double bolted, it is single bolted, single cover. This is a single cover plate we are providing. That's why it is called single cover. Single bolted means we are providing only one line. We should not consider this as two. So whenever we analyze and design a joint, we are going to consider only 50% of the joint, okay, one half of the joint, and we are going to analyze and design it, and whatever bolts, whatever spacing, whatever comes, we are going to replicate on the other side. So here it is a single bolted butt joint, single bolted, single cover, because we have only one cover plate provided. Okay, so coming to double cover single bolted joint, bolted butt joint, yeah, this is a double cover. We are providing two cover plates, one on the top and the other at the bottom, and we are providing bolts along only one line. If you look here and to the perpendicular, sorry, in the direction perpendicular to the paper, we have provided other bolts. Okay, so this is a double cover single bolted joint. As I said, when we consider analysis and design, we are going to consider only 50%, that is one side of the plate. So on one side there is only one line of bolt, so that is why it is called single bolted butt joint. Okay, next, so coming to different failures of connections. So there are different ways a connection may fail. So I am going to deal with those. So first one is shear failure of bolt. So see, when these two plates are connected using a lap joint and we are putting bolts, okay, when you apply force until the failure happens, if at all the failure is happening due to the failure of the bolt, that is shear failure of the bolt, so this is the way the bolt is going to fail. That means the bolt shears, okay, and there is only one surface. So that's why we are going to consider this as single shear failure, or in other words, we are going to say the bolt is in single shear. So you have to remember this, because for our example, for our design, we are going to first check whether the bolt is going to be in single shear or double shear. So coming to this figure, next figure, this is the main plate subjected to P, and this main plate is connected through these two smaller plates on both the sides. Okay, so that's why these two smaller plates, each plate is carrying P by 2 and P by 2. And this main plate is carrying P. When you connect them using a bolt, if at all the bolt fails by shear, the bolt fails along two planes. So look here. So this is the way the failure happens. So in this case, the bolt is in double shear. So in this case, the bolt is in single shear, and in this case, the bolt is in double shear. So this is very, very important. So just visualize it, because whatever problems we do in this module are on bolted connections, so 90% of the problems are on this. Okay, there is one more type, that is high strength friction grip bolt. So we are going to solve only one problem, that is more than enough. So other than that, so you need to understand what is this. Next, bearing failure of bolt. See, what is the other way a bolt can fail? So when you apply load, when you pull those two plates, so on one side, the bolt, presses against the plate, 50% of the diameter, okay, or 50% of the bolt is going to be in touch with the plate. So when they press against each other, when the plate presses against the bolt, when it is subjected to compression or tension, so bolt may fail like this. This is called bearing failure of bolt. This is also very important. This is also we are going to consider when we design. So shear failure or bearing failure. So bearing failure of bolt. So bearing means the bolt yields along or on the contact surface. What is the other type of bolt failure? Bending of bolts. So bolt may even bend. That is also considered as a failure. Next, this is also important, that is bearing failure of plate. So when you connect those two plates and pull those plates apart again, so this bolt, that is half the circumference of the bolt, presses against this plate. If this plate is weaker than the bolt, so then the plate yields first. Okay, that is bearing failure of the plate. Again, in design, as I said, we are going to deal with this. Next, shear failure of plate. So look here. So when you pull them apart, so the plate may fail along this line, This is called shear failure. When it is going to happen? When we don't provide end distance, adequate end distance, that means we are going to provide these bolts very close to the edge, then this kind of failure may happen. That's why the code specifies we have to maintain certain minimum end distance and also certain minimum edge distance. And you will know what is end distance and you will know what is edge distance in this class itself very soon. Okay. Next, tension failure of plate or tearing of plate. Again, this is a lap joint. Okay, one plate coming over the other, and we are connecting those two plates using a line of bolts here, these three bolts. So whenever we drill holes into the plates, so that section becomes very weak. And if at all the plate fails, then the plate may fail due to tearing of the plate. That means the plate may tear off and this part will separate from the main plate. That is called tearing of the plate. Okay, this is another failure. This is called prying action. Through prying action, bolt will fail due to tension. Okay, so say for example, this is a beam section, for example. This is hung by a plate. Okay, whenever you apply load on this I section, especially in case of cranes, okay, and this will try to come down, that is I section will try to come down. As a result, the edge presses against the top plate. So as a result of it, this bolt is going to be subjected to tension and the bolt may fail due to tension. That is called tensile failure of bolts. So coming to the bolt terminology, say if you look here in one of the examinations, it says explain the following terms: pitch of bolts, gauge distance, edge distance, staggered distance, tacking bolts. So these are the 5 things you need to explain briefly as per that question appeared during December 2010. And also one more question was in July 2016. It says mention the bolt terminology with a neat sketch of group of bolts. So what you need to do is you need to write this figure and you need to explain this. So if you look here, okay, 2 plates and we are connecting those 2 plates through butt joint. Okay, so each side is connected with 6 bolts and those 6 bolts are arranged along 2 lines. That means it is double bolted. Okay, double bolted, and also it is called chain bolting because everything is in a sequence. Whether you take this or you take this, you take this. Okay, so that's why it is called chain bolted double cover, because we are providing 2 cover plates. Butt joint means those 2 plates are, that is main plates, are coming face to face. So coming to bolt terminology, if you look here, I have written pitch. So it is the distance between 2 successive bolts in the direction of the applied force. If you look here, we have applied a tensile force of T. Okay, it may be even compression force. So in this direction, if you measure the distance between 2 successive bolts, then the distance is called the pitch. Okay, so instead, if you measure the distance between two successive bolts in the direction perpendicular to the direction of the applied force, it is called the gauge, represented by small g. Pitch is represented by small p. So this one more name for this gauge is called transverse pitch. Transverse pitch because it is applied or measured in the direction perpendicular to the main pitch. Okay, this is the main pitch. Next, coming to this, if you look here, this is the end distance. This is the end distance that is measured from the center of the outside line of bolt. See here, we have two lines of bolts. So this is the outside line. Okay, and this line of bolt is closest to this edge. Okay, from the outside line of bolt to the outside edge, from the center to the outside edge, that is called the end distance, and that is represented by small e. Okay, this distance is measured in the direction of the force. If you look here, again, from the center of the extreme bolt to the nearest edge, that is called the edge distance. Again, that is represented by small e. This edge distance is measured perpendicular to the direction of the applied force. Okay, I repeat, any distance between two successive bolts in the direction of the force is called the pitch, represented by small p. Okay, and the distance between two successive bolts in the direction perpendicular to the direction of the applied force is called the gauge or transverse pitch. And any distance measured in the direction of the force from the extreme line of bolts to the edge is called the end distance. And any distance measured to the edge of the plate from the center of the outside bolt is called the edge distance. Okay, I hope this is clear. And if you have your code book with you, so I don't know how many of you have the code book. Please open page number 73 of the code book. Please open it. I'm going to give you 2 minutes. So have you opened this? Page number 73. So I proceed. So if you go to the second column on page number 70, that is section 10 connections. So go to the second column, go to the bottom, it says 10.2.2 minimum spacing. Go to the end. 10.2.2 on page 73. So it says the distance between centers of fasteners shall not be less than 2.5 times the nominal diameter of the fastener. So what it means is, see, the pitch should be at least minimum P minimum. That is, whatever the pitch should be at least 2.5 times the diameter of the bolt. Say, for example, 20 millimeter is the diameter of the bolt. So 2.5 times 20 millimeter is 50 millimeter. So the minimum distance between the center of this bolt to the center of this bolt should be 2.5 times D, that is 50 millimeter. Okay, that is the minimum. So what is P max? What is the maximum distance you can cover? Again, if you go to the next page on page 74, it deals about maximum spacing. One is maximum spacing for pitch and the other is the maximum spacing for gauge. Okay, so now remember, so I'm going to apply the maximum spacing for the pitch part, and that is safely and adequately that is going to apply for the gauge as well. So if you go to 10.2.3.2, it says if a member is subjected to tension, the maximum spacing you can give is 16 times T, where T is the thickness of the thinner plate, sometimes you need to connect two plates of different thicknesses. Okay, in that case, you need to take the thickness of the thinner plate or 200 millimeter, whichever is smaller. That is going to be the maximum spacing of the bolts, that is the maximum pitch. And we can safely apply the same rule for the transverse pitch or the gauge. Okay, you remember that much? You don't. So if you go through this, it is given a lot of things. And again, if the member is subjected to compression, the same maximum pitch is going to be 12 times T or 200 millimeter, whichever is smaller. Okay, so if you remember that much, that should be enough. Okay, once we start solving the problem, you'll understand it clearly. Next. So what is this? See, this is a chain bolt. So everything is, if you go along this in one direction, so if you draw a line, all bolts lie in the same line, or if you draw a line like this, all bolts are lying in the same line. If you look here, so this is not chain bolting. Okay, this is a diamond bolting, wherein in diamond bolting, of course, we need one more bolt here to make it definitely a diamond bolting. So we can say this is staggered bolting. That is a better terminology. Staggered means, so there is no sequence. So we are going to put the bolts in a zigzag fashion. Okay, to increase the efficiency of the joint. You will understand what is efficiency of a joint when we go further. Okay, so if you go here, so when you say pitch, as I said in the previous case, in case of chain bolting, it is a distance between two successive bolts. So then that is going to be this, because it is staggered bolting. So this is the distance between two successive bolts, that is called staggered pitch. Okay, so I have given brief explanation on pitch, staggered pitch, okay, gauge or transverse pitch. So if you look here under pitch, small p, so the center to center distance between individual fasteners in a line in the direction of the load or stress is called the pitch. So what is P minimum? That is going to be 2.5 times D as per 10.2.2 page 73, which I discussed with you just now. Similarly, P max is according to 10.2.3.2 page 74. Okay, so that is the way maximum pitch and minimum pitch are maintained. And whatever pitch you give for bolts, so that pitch should be greater than equal to P minimum, that is minimum value of the pitch, and less than equal to P maximum, that is a maximum value of the pitch. Okay, that is equally applicable for staggered pitch and also for gauge. So for gauge, again 10.2.3, okay, page 74. So next, when it comes to edge and end distances. Yeah, I explained it already. So what is the edge distance? Edge distance is measured here. Look here, edge distance is measured from the center of the extreme bolt to the nearest edge, that is the edge distance. Similarly, and this is measured in the direction perpendicular to the application of the force. Similarly, when we measure the end distance, so we are going to take the extreme bolt and we go in the direction of the applied force. Okay, we are going to measure it. That is the end distance. Okay, what is P? And we are going to represent those two things as E. So what is E minimum and what is E maximum? So for that, if you go to again page number 74 of the code, so first column, it says, and go to 10.2.4.2. 10.2.4.2. So if it says 1.7 times the hole diameter in case of shear or hand flame cut edges, or 1.5 times the hole diameter in case of rolled. So I need to tell you about what is the hole diameter and what is the bolt diameter. See, whenever we put bolts, say for example 20 millimeter bolt, we are not going to drill 20 millimeter diameter hole. Instead, we are going to drill 20 plus 2 millimeter extra. So 22 millimeter diameter hole. Okay. So where did I get the 2 millimeter? Again, go back to page 73. If you look at table 19, okay. If you look at table 19, so it says nominal size of fastener. Fastener means it is bolt in this case. If the diameter of the bolt is 12 to 14 millimeter, so diameter of the hole is going to be diameter of the bolt plus 1 millimeter extra. So standard clearance in diameter and width of slot and oversized clearance in diameter, there are different cases. Okay. So we are going to deal with only the first one, that is standard clearance in diameter and width of slot. So width of slot, you don't worry, just standard clearance in diameter you think about. Okay. If the bolt diameter is 16 to 22 millimeter, say for example, if we are using 16 millimeter bolt diameter or 20 millimeter bolt diameter or 22 millimeter bolt diameter. So whatever bolt diameter is there, you need to drill another additional 2 millimeter extra. Okay, that is for 20 millimeter or 22 millimeter bolt, you need to drill 24 millimeter bolt hole. Okay, it is given as per the code. If anything beyond 24 and above, again it is 2 millimeter, and larger than 24 millimeter. If the diameter of the bolt is bigger than 24 millimeter, then we are going to drill a bolt hole of 24 plus 3 millimeter, that is 27 millimeter diameter of the bolt hole. Okay. So next, coming back to edge and end distances. See here. So if you go to 10.2.42, it says, so the minimum end distance should be 1.57 times the diameter of the hole or 1.5 times the diameter of the hole. So it gives two options, whether you go for 1.7 times multiplied by diameter of the hole or 1.5 times. So that depends on the condition of the edge. See, if you look at this figure, if you look at this edge, if this is hand cut, for example, if this is hand cut means this edge is going to be rough. So this edge is not well defined, it is rough. So it is not a sharp cut. Okay. Then you need to go with higher end distance. Higher end distance means 1.7 times the diameter of the hole. Okay. If it is a machine cut, this edge is going to be perfect. It's okay. It is a sharp edge. In this case, because we know the exact edge, we are definite about it, then we can provide or we can reduce the end distance, and that is given by 1.5 times the diameter of the hole. Okay. So next, tacking bolts. So tacking bolts. So I think please, when I take class, so please remind me, I can explain it, because in case of trusses, what we do is, if the truss member length goes beyond certain length, say, okay, then what we do is, if you are putting two angles together, okay, the design requires that we need to provide two angles back to back, for example. Okay. So what we do is, we are going to tack those or stitch those two angles together using tacking bolts. Okay. That is, it is like giving a tack. Okay. And we don't consider tacking bolts for any design. Is it clear to you? So next comes grade and classification of bolts. I told you, grade and classification of bolts. So we have different, grades of bolts. Bolts are represented as grade 3.6, 4.6, 5.6, 8.8, okay, 8.9, 10.9, etc. There are different grades of bolts. Okay. And what we are going to make use of here is, in majority of the cases, is 4.6 bolt. So when I say black bolt, ordinary bolt, okay, grade C bolt, means it is 4.6 bolt. So what is this 4 and what is this 0.6? See, if I look here, if I take this 3.6 volt, I've explained this here. Grade or class 3.6 volt means if you take this 3 value and multiply that value by 100, that is going to give you the nominal ultimate tensile strength of that particular bolt. Okay, 3 means 300 Newton per millimeter square is the tensile strength of the bolt. Then what is this 0.6? So that 0.6 is nothing but yield strength divided by nominal ultimate tensile strength. That is equal to 0.6. So where did I get this 0.6? This is what that value is. Okay. Then what is that nominal ultimate tensile strength? That is 300. So 300 multiplied by 0.6, that is equal to 180. And 180 is the yield strength of the bolt. 300 Newton per millimeter square is the ultimate tensile strength of the bolt. And 180 Newton per millimeter square is the yield strength of the bolt. Similarly, if we take one more bolt, grade 6.8. So as I said, if you take this 6 multiplied by 100, that is going to give the ultimate tensile strength of the bolt. That is 600 Newton per millimeter square. Okay. Then what is the yield strength of the bolt? That 600 multiplied by 0.8, that is 480, will give you the yield strength of that bolt. Okay. So it rarely appears in the examination. This question is not too common, but sometimes it may appear. So similarly, we have in steel construction, bolts of property classes 4.6, 5.6, 8.8 and 10.9 are generally used. Even though we have different grades of bolts, mainly we are going to make use of these 4 grades of bolts for the construction purpose. That's why in majority of the cases, these bolts are available. Okay. So any doubt regarding this, guys? So I'm going to start with strength and efficiency of joint in the next class. Okay. So afterwards, I'm going to start with the problems. I'm going to explain the problem. Hopefully you'll have the code book with you by then. I'm going to start next class. I think it is on Monday. Please be ready with the code books. Okay, that is IS 800 and steel table. So I know it is hard to get those 2 books as of now. Somehow you have to make it. Okay, there is no other choice for us. So make use of 6 to 10 every day morning time slot, and if possible, try to get Xerox copy and get it bound. Okay, and keep that book with you. So those 2 books are allowed in the examination. Okay, and without those 2 books, you cannot do anything. Okay, guys, thank you very much, and be safe. Okay, don't go outside too much. So the corona is spreading like wildfire. Okay, stay home, be safe. See you on Monday. Thank you, guys.
Thank you, sir. Thank you.
Thank you, sir.